Continuation from where we stop. Simple harmonic motion. I remain your favorite tutor. All right, today we're talking about what? Period of a simple pendulum. Please, if you didn't get my previous video, you can always go back to previous video. Okay, no time. Period of a simple pendulum. Let's say, for example, this is a what? A pendulum bob. This is a pendulum bob. Now we are going to derive the equation for period of a simple pendulum. It is very easy to derive. If it is a pendulum bob, if I want it to observe simple harmonic motion, I have to do what? To extend it. I have to create a distance. That is, if I take this bulb to this end, to this other side, at this point, I have an angle, theta. So right here, from this distance, this is the center position, which is what? The mean position. That's the center of oscillation. This is the length of the string. Same thing right here. They are opposed to each other. So from here to here, right here, this forms what? An arc. That is what? X. Let's call it X, arc of a circle. So right here. So therefore, if I extend this bulb to this end, there is a force. If I leave it, there's a force that will take it back, that is pulling it back to the what? To the center of motion. There's a force that will take it back to the center of motion. That force, we call it the restoring force. And we are going to look for it. Now, the force taking it downward is what? That is mg, the weight of the what? The bulb. This is the resultant force. If this is the resultant force, we are going to resolve it to the what? To the restoring force. The force taking it to what? Center of what? Oscillation. Okay, if this is the what? The resultant force, we are going to resolve it to this force. If this is the resultant force, this line is parallel to this line. This line is parallel to this line. If I add to this line, let us see. You see this line? If I add to it, I'm going to form an angle right here. This is a corresponding angle to this angle. These two angles, they are what? Corresponding angles. So therefore, since I'm resolving it right here to this force, this is the resultant force. I'm going to just create what? 90-degree box right here. So therefore, I'm going to resolve this to this component. This is the resultant force. I'm going to resolve it to this component, which is very easy to resolve. We see this one, this component. That's the resultant force, which is what? Opposite what? The 90-degree box. The line opposite the 90-degree box is known as what? The hypotenuse. So therefore, this line is what? The hypotenuse. And then you see this angle here, theta. We brought it right here. This is what? Theta. Can you see that? These are what? Alternate angles. Now, since these are alternate angles, I want to resolve this to this force. I want to get the force acting right here. Taking it back to what? Center of what? Motion. It's very easy to resolve. Right here, I'm looking for this. I'm looking for this force right here. Since I'm looking for this force right here, so therefore, that is, I'm looking for this line. That is, I have what? Hypotenuse. I am looking for what? Opposites. Just like I have hypotenuse, I'm looking for what? Opposites. So, what do I use? Which trig function have opposite and hypotenuse? That is sine. So that is sine theta is equals to what? Opposites over what? Hypotenuse, which is what? mg. And what is the opposite? The opposite is the force right here, which is F. So therefore, if we cross multiply, opposites is equals to, this is what? mg sine theta. And the opposite is the force, that's the restoring force. So therefore, restoring force is equals to mg sine theta. So therefore, this force is what? Mg sine theta. Taking it back to what? The mean position. So therefore, we say that what F is equals to mg sine theta. Mind you, force right here is the same thing as what? MA. That is what MA equals to. Now this is sine theta, degree, taken in form of degree. Mind you, for what we have been doing before, theta is in radians. Theta is in radians. For this case, whereby the angle here is very small. For this case, whereby the angle here is very small, let us say less than 10. The angle right here is very small. You can say that what? Sine theta is approximately theta in what? In radians. Sine theta is approximately what? Theta in what? In radians. So since we are using radians, this is what? Mg theta in what? Radians. From here we can deduce the fact that what? Mass will take away mass right here. So what is the acceleration? Acceleration is equals to what? That is g theta. What is theta? Theta in this case right here, remember, this is the arc of a circle, which is what? X. Know that x, which is arc of a circle, from what we did in our previous class, is what? That is theta times what? Radius. In this case, what is the radius? We are not using radius. Radius is the what? That is the length of the string. That is the length. So if I make theta here subject formula, theta becomes what? X, which is the distance. This is the distance from the mean position over what? Length. So we put it right here. That is the distance over what? Length. Mind you, from what we did last time, we deduced the fact that for a body to execute simple harmonic motion, the acceleration is directly proportional to the what? To the distance. This X stands for the distance or the displacement. And this acceleration and distance, they are opposite each other. The acceleration is directed towards the center of motion. Therefore, A is equals to minus G. That is what? X over what? Length. Let's make it look beautiful. I can also say that A is equals to minus G over length. Then what? X. Now, if this is the acceleration in this case, now if we compare it, this is acceleration at a distance. If we compare it to our normal acceleration at any distance, let's compare it to normal acceleration at any distance from previous class. That is A is equals to minus omega squared, then what? X. If we compare these two, discover that A is equals to A, X is equals to X, then omega squared is equals to this. So therefore I can say that what? Angular speed raised to the power of 2 is equals to what? G over what? Length. So therefore I can say that what? Omega squared is equals to, that is what? Square root of G over square root of length. I hope you can see this. No, sorry, remove this. So therefore, what is omega? Know that we are looking for period. Period of a pendulum, of a simple pendulum. Now, what is omega? Omega is equals to what? 2 pi over what? Period. Now, this is the period. Since omega is equals to 2 pi over period, we'll put it right here. So therefore, 2 pi over period is equals to, which is omega, is equals to square root of G over what? Square root of length. So if we take the inverse of the left-hand side, we take the inverse. We have to make this a numerator. We want to isolate this period. Take the inverse of the left, take the inverse of the right. So this is what? Period over what? 2 pi is equals to, at the square root of length over what? Square root of what? G, taking inverse of both sides. So take this to this side, 2 pi. That is period is equals to what? 2 pi times what? Square root length over square root G. You can see how beautiful it is. It's just the same thing when you cross multiply, divide both sides by the coefficient. You have it. So therefore, we can say that period is equals to 2 pi. Then what? Length over what? G. This is what? Period of a what? Simple pendulum. Please, I hope you got this. You can take your time and put it down. All right, good news. We have a lecture center in Benin City. Quest tutorial. Make sure you are there. If you are in Benin, you are a student, make sure you are there at number 1 Urubi, opposite Yoruba Street, off Iyaro, just beside the waterboard. You meet us there. We are having classes for all students: science, social science, and arts, preparing students for tertiary institution. And then class is ongoing, back to back. Make sure you are there. It's very, very interesting. Very, very interesting. If you are coming, come with all your problems, come with all your questions. We'll make sure we dissolve it. I remain your favorite tutor. Thank you, and God bless you. And please don't forget to subscribe to my YouTube channel. You have the full package on mathematics, everything you need to know on what? Physics, all the topics for both SSC and UTME questions. Thank you, and God bless you.